Hello, this is Conra, and I wanted to talk to you for a minute about factoring quadratics. I have a slightly different visual approach to this. My goal is to get you to try this a couple of times, doing it my kind of silly way, and then see if you start to notice things. My goal is to get you to train your eye to go to the right spot when you are factoring these things, so that you don't get caught up in all the letters and numbers and symbols. Okay, so we are talking about quadratics that have a 1x squared there. It's an implied 1. You can see that I have grayed out a couple of steps here. We are doing a simplified version of the general case. So the general case would work on these as well, but we get to skip a couple of steps because there's a 1 in front. So these are much quicker than the problems where you have a different number out front. That number out front is the leading coefficient, and we often call it the number A. And then the number in front of X is going to be what we call B, and we include that sign as part of it. And the number at the end, the constant term, is what we call C. Step 1, we want to make sure that we know what number is in that spot. Also part of step 1, we want to see what is in that spot, C, and we are going to use those two numbers. So we're going to find a pair of numbers that satisfy two conditions. We want the answer after we multiply it to be this number here. And the second fact that we want to be true is we want that pair of numbers to add up to this number B. So that we are looking for a special pair of numbers that satisfies two conditions. So like I said, in this case, you get to skip these extra steps. And it turns out that you can put that first number that you find in that spot, and you can put the second number in that spot. And they're interchangeable. It doesn't matter which one's which because that's multiplication, and multiplication is commutative. So, okay, let's do an example problem. So the first thing I do is I make sure that there is a 1 in that spot there. There's an implied 1. That means that I can do the simple version of this problem, this set of steps. So once I notice that, then I can see, I go looking for the number in front of X. We're going to call that number B. So in this case, B is the number 9. And then I go looking for the constant term. And there's a negative in front of there, so I'm going to say that C is negative 22. So I am looking for a pair of numbers so that when I multiply the pair of numbers, the answer to the multiplication is negative 22. And the answer to the addition is B, which is 9. So sometimes those numbers pop out at you. Sometimes you have to think about it a little bit. Here is a methodical way to do it that you just do it. You don't really have to think about it. You don't have to be artistic or tricky or whatever. So I'm just going to start with 1. And I'm going to list out pairs of numbers that multiply to C. In this case, my C is negative 22. So if I start with 1, I see that 1 goes into negative 22 times. I'll try 2. 2 goes in negative 11 times. 3 does not cleanly go into 22. Notice that 2 and 11 are both prime. I'm not going to find any more numbers between 2 and 11 that go into it, but I can try them. Get out your calculator, see if they work. We want the answer to the division problem to be an integer. That's what we mean by going into it. In this problem, I'll go ahead and try change signs. So I can use negative 1, and that goes in 22 times. And I can use negative 2, and that's going to go in positive 11 times. So I'm out of options. So now I'm going to go through and add all of these together. So 1 plus negative 22 is negative 21. 2 plus negative 11 is negative 9. Negative 1 plus 22 is positive 21. And negative 2 plus 11 is positive 9. So my goal is to go through, and I'm looking for B to occur in the second column. So in this case, my B was a 9. So I'm looking for a 9 in this column, positive 9 specifically. And I see that in this fourth row, my answer was 9. So it's a good idea to double check. You don't want to go further with the wrong numbers. So we'll stop and we'll double check. I'm going to put these numbers in the spots. And I want to make sure that that pair of numbers, if I multiply that pair of numbers, I get negative 22. And if I add the same pair of numbers, I get 9. So I double check, and that works. For consistency, I went ahead and called this step 5. I wanted to emphasize that we get to skip a couple of steps since a is equal to 1. From the previous step, I saw that my numbers were negative 2 and positive 11. If I want to write that more cleanly, I could write x minus 2 times x plus 11. And we can always check using multiplication. See if I can squeeze this in here. So if I multiply those out, let's see, my first is x squared, and my last is negative 22, and my inner is negative 2x, and my outer is 11x. So I add those two together and I get a positive 9x. So I'm going to double check. I have x squared, so that's my x squared. And I have a 9x, and that's my 9x. And I have a negative 22, and there's my negative 22. So I have just shown that my answer to my factorization, if you can read it anymore, is x minus 2 times x plus 11. Thanks for listening. I will talk to you later.